Alright, so today we're working with our 5. And I would like you to start out by making a 5 by 9 array. Lainey looking at me like, holy moly, Miss Muller, that's going to take a little effort. You're not wrong, Lainey. It is going to take a long time. So instead of making a 5 by 9 array, we're going to do what I call a fast array. A fast array. So underneath our question, I want you to write fast array. Underneath your title, we're just going to put a fast array. And the definition, Kylie, you're writing, not messing with your counters. The definition of a fast array is on my board. It's just an outline of an array that you can create easily to skip count. It's not going to take 800 years like a real array. It's just a fast one. And I'll show you what that looks like in a minute. Hunter, you're writing this underneath your title. Thanks. So you should be writing. Which pencil? There you go. So Kylie just brought up a good point. She said, I like the fast array when it's something I can skip count easy by, like 2s or 5s, because I know I can just put my finger on each one and skip count. This might be a harder strategy for 4s. I know I'm not good at skip counting by 4s. If you are, go for it. That just does not make my brain happy. But if it makes your brain happy, go to town. Dorian, what's up?
First of all, as long as the pin
Sure.
Like it doesn't make your head happy, but it might make it hurt.
Sure.
And also, well, I think that like the circles and dots for like kind of like the reasons below, like it's like 5 times something.
Sure.
5 times 6. So I like to use circles and dots, and then like and I think.
So Dorian just did a really great job explaining all the different strategies and when it makes sense for his brain to use them. And that's fine. Change up your strategies. I like it. I'm a fan. All right, on your desk, create a fast array for 5 by 7. 5 by 7. What is a fast array for a 5 by 7 going to look like? Once you've got a fast array for 5 by 7, solve it and put one hand on your head when you have the product. So I know you are ready to go. All right, Barrett, what did we figure out 5 by 7 equals? Use your fast array. Skip count using your fast array. Nope. Count how many columns you have. You might have too many. Should be a 5 by 7. William? Nope, you have too many dots there. Lily Marie? Should equal 35. Your fast array, if you made it, should be 5 down. Most of you got that part right. But don't skip our first column. Okay, put that on my desk and unpack, okay? So 1, 2, 3, 4, 5, 6, 7. Okay, that's random dot. Can be red, that's cool. You'll find my board likes to change colors on me sometimes. Now I'm going to skip count. Skip count with me. Ready? 5, 10, 15, 20, 25, 30, 35. No, I made it green, but the red dot I didn't make red. All right, we already did a 5 by 9. Make a 5 by 11 fast array. And put one hand on your nose when you have the answer. 5 by 11 fast array. And then one finger on your nose when you figured. All right, what do we got? What do we got? Geo, what is 5 times 11? 55. Give me a thumbs up if you know how to make a fast array. Give me a thumbs up if you know how to make a fast array. I don't care if it's your favorite. I just want to know if you know how. Really, you know how? Yes? Someone's in the middle, you're like, thumbs up is good. Alright. Today we're going to work on our fives. Fives are usually pretty easy ones. So go ahead and move all of your counters towards your name. Awesome. I'm going to give you another hundreds chart. Just like we did yesterday, but instead of coloring in our 2s or our 4s, you're going to color in just our 5s with a yellow crayon. So while you're waiting for me, get out a glue stick and a yellow crayon because you're going to start gluing in that hundreds chart and coloring in your 5. Alright, so we should probably have quite a few products colored in. Hundreds chart should look something like this by now. Oh. Alright, what patterns do you see? On the same page that you glued in your hundreds chart, we're going to write down some patterns that we see. Actually, nope, that was a lie. On the same page that we did our 5s, and if you need more room, you can put it on the next page. We're going to write down some patterns that we see. What was one pattern you saw when we were coloring in our products of 5? Mason, what did you see?
I saw that we just had to go to 5 and then.
Okay, is that it?
I remember that it was all I have to do was just go to the 5 and then go down to the bottom of the.
No, I know. Is that the only thing you colored?
And go to 10 down.
Look at the ones column. If it skip counts by 5, the ones in that product is either a 5 or a 0. Look at what you colored. Everything that you colored either ends in a 5 or a 0. So if I say 5 times 2 is 22, could that ever be right? No, because 22 is never, ever, ever going to work with 5s.
And also it does equal 10.
Yeah, also my math was wrong. Alright, so we're writing down all 5 products end in a 5 or a 0. Which is why you've colored basically 2 lines down your hundreds chart. Hunter, this is the part where you're writing. Macy, you got this written down? What else do we see? What other pattern do we got? Kylie?
Also counting by 10s and 1 row.
Okay, but we're not counting by 10s, we're counting by 5s.
No, like, after you 5, 10, 15, after you colored them all in, and after you colored them into a line, which is also counting by 10.
Gio? Yep, we know that because it ends in a 5 or a 0. Dorian?
I noticed something in that, pretty good, like, with all the 5s, like, it just, like, there's, like, 1 and 0, 2 and 0.
Yep. Remember when we did our 2s and all the products of a 2 were even? Is that the case with 5s?
No.
Are all the products odd?
No.
Oh, what do we notice about the products? Cade, what do you notice?
That, whatever the number is, if it's even or odd, that's what all other numbers are going to be.
What do you mean?
Like, so, if this is 5, then that number is odd. Because the ending number is still
Not every product is odd.
I know, but
No, it's not. Every product times 5 is not odd. Ashton?
the 5 is odd and then it goes.
Oh, so it goes odd and then even. And then odd and then even.
That's and then also hard to avoid.
What?
That if between the lines there's 4 fifths.
Uh-huh, because we're counting by 5. So we color in every 5th number. So our products go odd and then even. And then odd, and then I'm just going to put ETC, which means so on and so on. Not all the products are odd, and not all the products are even. The ones that end in that 0 are even products, and the ones that end in a 5 are our odd products. Yes, ma'am. Yes. With your counters, I want you to make a 5 by 2 real array, not a fast one this time, in yellow, and then another 5 by 2 array in red. So you're going to make a 5 by 2 in yellow and then a 5 by 2 in red. Yes, Hunter?
We're supposed to doing our number chart.
Yeah, you should have already done that, love. Alright, here are my 2 5 by 2 arrays. I'm going to smush them together. Make sure yours is smushed together the right way so that I have a 10 by 2. Make sure yours gets smushed together the right way. Some of you are making a 4 by 5. I want a 10 by 2. So look at how mine is arranged. And you need to arrange yours like that, please. Billy, you don't even have a 5 by 2 array yet. Come on, dude. So it should be a really long, skinny array. Lily Marie, that is not a 10 by 2. Mason, that's not a 10 by 2. Alright, underneath your red array that you've drawn in your notebook, I want you to write the name of it. That is a 5 by 2. And we're going to put it in parentheses. You can do it in crayon or you can do it in pencil, whatever makes your brain happy. Alright, and then next to that 5 by 2, just like on your desk, it might be helpful if you use an orange crayon just so you can see it a little better. I want you to draw the yellow 5 by 2 just like on your desk. So we're going to draw it right next to our red one. It is okay if you want to make it orange in your notebook just so you can see it a little better. And then we're going to do the same thing. We're going to name our yellow 5 by 2. So now our paper matches our array that we have on our desk. So now we've smushed them together, we've added them, and together, when we smush them together, we make a giant 10 by 2. So we had our 5 by 2, our other 5 by 2, and smushing them together, we got our total. Does this remind you of anything that you might have learned before? Does it remind you of anything that maybe you've learned before, maybe in second grade? Where you have one section, another section, and then they come together. William? Part, whole. This is exactly that. It's just the third grade version. This is one part. Go ahead and label in your notebook. This is your other part. And when we smush them together, we get our whole. Part, whole is not just for addition and subtraction. It's also for multiplication. We'll find out. Bria?
Actually, do know what 10 times 2 is.
Great. I don't need to know what 10 times 2 is. But I do need to know that I can break apart a math fact into a part and a part and smush them together to get the whole. Make sure your paper looks like mine with the part, whole, please. Good chart. We know our 5s and our 10s are connected because we just made them connected, right? 2 5s gave us a 10. 2 5 parts gave us our whole 10. So now on your hundreds chart in blue, I want you to color the products of our 10s blue. Let me go back to my hundreds chart. Here we are. I hear a lot of you saying, hey, that's making that green again, kind of like we did with 2s and 4s. What does that mean? What does that mean? You guys are, I'm hearing you say, hey, we're making that 10 kind of a green shade because we already colored it yellow. So what does that mean? Think back to what we learned with 2s and 4s when that happened. What does that mean for our 5s and 10s? Bria, you're on fire today. What does that mean?
That it might equal the same thing.
Okay, so we know that some, if I'm writing, you're writing, of our, 5s and 10s equal the same product, right? If they're colored the same color, then they are equaling the same product. What else do we know then? What else do you know? Kylie?
Each time you add a 5, it goes to the next yellow one, and it adds 5 more each time, so it's going to each equal one of the 10s.
Good. So Kylie's noticing that it's kind of going yellow and then green, and then yellow and then green, and then yellow and green. That same thing happened on our 2s and 4s.
It's like a ton.
Why did that pattern happen? Remember, we gave our 2s and 4s a special name because they were doing that. Okay, do you remember? Doubles. Our 10s are just the 5s doubled. The 10s are just the 5s doubled. So if I know one part, 5 times 2, and I add another part, another 5 times 2, I can add those two things up and get 10 times 2. Like we just did. Someone remind me, what was 5 times 2? I know you can do this because you just skip count 2 times. 5 times 2. Kylie? 10. Plus another 5 times 2. What is 5 times 2? Lainey, remember? 5 times 2. Skip count by 5 2 times. 10. So we have 10 plus 10 What is 10 plus 10?
20.
20. So what does that mean 10 times 2 is?
20.
20. Because all we're doing is just doubling our products. Cool stuff, huh?
Wait, 10 plus 10.
Yep. Yep. Once you got these notes down, go back to our mini multiplication chart. We got some math facts to add. Bria, put your finger on the top 5 right here. Hunter, come on, switch counters. Put your fingers on the 0 here. Drag until they meet. What is 5 times 0? Barrett? 0. All right, let's do it again. 5 here. Now we're going to be on the 1. Drag until they meet. What is 5 times 1? 5. We already have that one filled out. Let's do 5 and 2. What is 5 times 2? 10. We already have that filled out. 5 times 3. What is 5 times 3? What is 5 times 3? Billy, what's 5 times 3? 15. We're going to record it in our 5s. Make sure you're in the 5s column. Make sure you're in the 5s column. All right, what about 5 times 4? 5 times 4. Ashlyn? 20. What about 5 times 5? What about 5 times 5? Thomas, give it a go. Very good. 5 times 6. Hunter? We're filling out our chart. Are you with me? Get with me. Gio, what's 5 times 6? 30. Very good. Cade, 5 times 7? 35. So do I have to, if I'm doing 5 times 8, do I have to start over at 5, 10, 15? No, I can just count on. One more group of 5. Great. Great strategy. Kylie, 5 times 8? 40. Lainey, 4 times 9, 5 times 9, sorry. 45, very good. Mason, 5 times 10. 50. Anything else I can fill out with my 5s? Anything else I can fill out with my 5s? Anything else? William? The what? The top? What do you mean by the top? Explain that to me. Like going sideways? Yes, you can fill out going sideways. Why? Why? Because now it's going to say 3 times 5. But we did 5 times 3. Why can I fill it out going sideways? Ashlyn? We have a fancy math name for that. The commutative property. The what?
Commutative property.
The what?
Commutative property.
It means I can flip my factors, or the parts of my math equation, around, and the value is still the same. So now we are going to go 3, nope, 0 right here, times 5. 0 times 5. What is 0 times 5, Hunter? 0. What about 1 times 5, Lily Marie? 1 times 5. 5. What? 5. We already have that written in. What about 2 times 5, Kate? 10. That's already written in. Barrett, what about 3 times 5?
15.
15. We're going to record that right here. 15. What about 4 times 5? Billy?
4 times 5?
Yep. 20. Good. What about 5 times 5? Hey! We already have something written there. How did that happen? How does that happen? How do we have that number already filled out? Thomas? So? What equation gives me 25? 5 times what gives me 25? Nope. Dorian, what times 5 gives me 25?
5.
5 times 5. Can I rearrange 5 times 5?
No, they're both the same.
Yeah, they're the same. So we only have 125 because I can't really switch it because it's still the same thing.
Switch it. You would just be like 5 times 5, then switch it around. 5 times 5.
I know. Mason, what's 5 times 6? Or sorry, 6 times 5. What's 6 times 5? 30. Very good. Riley Early, what's 7 times 5? 35. Hunter, 8 times 5. Yep. 40. William, 9 times 5. 45. Very good. Nick, 10 times 5. 50. Very good. All right, we filled out our 5s. Can we fill out our 10s? Yeah. Let's go down first. So we have 0, 10, 20, 30, 50, 60, 70, 80, 90, 100. Anything else I can fill out with my 10s? Anything else I can fill out with my 10s? Oh, man. Anything else I can fill out with my 10s? Mason?
200.
No. I don't have 200 on there. No, that's not funny. He's given a good answer. I could. It will equal. I will multiply by 10 to get 200, but I don't have that spot. Bria, anything else I can fill out on my chart with my 10s?
You can flip around and do it sideways.
I can flip it around and do it sideways. What is that called? Way to go, Bria. Bria is on fire today. You guys should be jealous. No, she's been raising her hand. I've been picking on you. You've been raising your hand. Some of you other ones have not been raising your hand. Yes, Bria. All right, let's do our bottom now because we know from the commutative property we can also go sideways. 10 times 0 is what?
0.
10 times 1.
10.
I'm saying this backwards. 2 times 10. 20. Come on, guys. 3 times 10.
30.
4 times 10.
40.
5 times 10.
50.
6 times 10.
60.
7 times 10.
70.
8 times 10.
80.
9 times 10.
90.
Hey!
100.
Why did we already fill in our 10 times 10? How did that already happen? How did we already fill in 10 times 10? How did that already happen? You know. William, why? Why did that already happen? Okay. How is going down help us do it sideways? What was that equation? What was our last equation, William? 10 times 10. Can I flip 10 times 10?
No.
If I switch 10 times 10, my equation is still 10 times 10. So I already know the answer. I can't really change that one. It just is what it is. All right, once you have filled out your mini multiplication chart, take a look at all the multiplications you know. You know quite a bit. We have not done 3s and 4s. We've done 4s. Oh, did we not fill out our 4s?
No.
Oh, man. All right, let's